Good morning, doctor. My name is Cheong Ming AE190105. Now I will present the 7.1.1 program. The program are in online mode. The ladder diagram consists of two input, which is x1 and x2, and one output, which is y0. The input are both normally closed, are connected in series with the output y0. So when the both input is y0, the output y0 will become 1. When 1 is 0, 1 is 1, the output will become 0. When 1 become 1, when both input are 1, the output will become 0. When this become 0, 1, 0, the output will get 0. That's all. Thank you. Next, I will show program 7.1.2. The program is in online mode. The ladder diagram consists of 5 inputs, which is x1, x2, x3, x4, and x5, and 2 outputs, which is y0 and y1. For the first network, the x1 and x2 were normally open and connected in series with output y0. For the second network, input x3 and x5 are normally open, while input x4 was normally closed and connected in series with output y1. Next, I will show the result. When 5 inputs are 0, the output y0 and y1 also 0. If I change this to 1, the output is 0 also. If I change this to 1, y0 will become 1, while y1 will stay still 0. Next, I will show if this become 1, then the y0 and 1 is 1. So based on the result, to get output y0 equals to 1, y1, x1 and x2 must be set to 1 because they are normally open and connected in series. To get output y1 equals to 1, x3 and x5 must be set to 1 and x4 set to 0. To get y0 and y1 equals to 1, x1, x2, x3 and x5 must set to 1 while x4 is set to 0. That's all. Thank you.
Hello, Assalamualaikum and hi, my name is Abdul Rahman Sokri. My matric number is DE180017. Okay, today for my part, I will present for the lab MRIB2. For my part is 7.1.3. Okay, first, we have two network in 7.1.3, which is network 1 and network 2. For network 2, we have 5 input and 2 output. For network 2, we have 2 input and 1 output. Okay, first we test for network 1, which is if the S1 is on. Okay, as you can see, when S1 is on, the output Y1 will also on. Okay, but when I try to off the S5, okay, I on the S5. Okay, when I on the S5, the output will become 0, which is because at 5 from normally closed become normally open. Okay, so we off S5 again, and then which is the output will turn on. Okay, now we try to off for S1. Okay, now for network 2, which is 2 input and 1 output. When we turn on the S7, okay, the output also will be turned on, will become 1. Okay, but when we turn on also at 6, both are turned on. Okay, there is output is become 0. Now we turn off for the S6, which is from normally open, it become normally closed. Okay, now we'll set off for S7. Okay, that for 7.1.3. Now I will go through the 7.1.4. Okay. For 7.1.4, we have 8 input, which is x1, x2, x3, x4, x5, x6, x7, and x9. That's for input. Then we have one output, which is y0. Okay, we want to test if we turn on x1, what will happen to the output. Okay, now we turn on the x1. Okay, there is no output because the supply cannot go through the x3. Okay, now we on also x3. Okay, the output will become 1 because the supply can flow through the x3, then through the x9, which is in off position and normally closed. That's why the output will turn on. Okay, now we try to turn on at 7, and then we turn off the S1. What will happen? Okay, the output also is still 1 because the supply can go through the S7. If we turn on at 6 also, it will be on. The supply can go through the S5 and S6 and also at 7. Okay, I think that's all for my part. Thank you.
Hello, my name is Audrey, Priscilla, Riti, and Bakang with matrix number CE190154. I will be explaining the questions for 7.2 and 7.3. For question 7.2, what will happen if the user did not click online mode when executing the program? For example, this is the letter diagram, and we just click run. Therefore, nothing will happen if we do not click the online mode. As you can see from the bottom part here, we can see that the program is not online, but the simulation is run. And you can see that from the ladder diagram, there is no produce any output. The online mode can be represented as the current flow when it's clicked. Therefore, when we click on the simulation but not the online mode, there is no output produced based on the ladder diagram. Next, for the question 7.3, modify the figure from question 7.13 so that the lamp Y0 or Y1 will always on. Basically, this is the ladder diagram for 7.1.3. The question asks me to modify the diagram of 7.1.3. Since we only want Y0 or Y1 to always on, we modify the ladder diagram of network 1 only. On the screen shown is the modified ladder diagram. We modified the diagram by splitting the contacts and outputs into two branches, which is x1, x2, x3 to y0, and then split into x4, x5, and y1. For example, if we choose y0, the first branch of the ladder diagram, which is x1 and x3, is changed to normally closed contact or NC. Originally, the x1 and x3 is normally open contact. Next, when we compile tools, okay, and we click the online mode, so it's running. When we click on the online mode, you can see that the Y0 is on, but not the Y1. And then we run simulation. Therefore, you can see that x1, x2, x3, and the output Y0 is always on. This is because NC contact will always allow the current to flow, which will cause the output Y0 to always on. In the second branch, X4 is changed to normally open contact, which is originally is a normally closed contact, where the current is cut off or cannot flow. Y1 will only on when X4 is forced to turn on. That's all from me. Thank you.
Good morning, doctor. My name is Cheong Ming Lee, AE 190105. Today I will present discussion and conclusion. I will present discussion first. In this lab, we have successfully installed the Delta Ispsoft We are required to simulate normally open or normally closed ladder diagram in single and multiple networks. We know to run the program after the program are in online mode. For the inputs, we can change the name and their state based on the questions. Then we observe the output and record in the truth table. We can analyze the program based on the truth table result. Next is conclusion. After this lab, we are familiar the techniques to program PLC using programming Ispsoft. We know to simulate the 4 programs that are given in the lab sheet and build truth table for each program. We know how to build up simple programs, run and troubleshooting. After this experiment, we gain the knowledge of using this software and build the programs. We become more confident and gain a lot of knowledge, and this will help us in future academic or our career. That's all for me. Thank you, Doctor.